Gate coordinate November.
Tango, this is Delta Kilo 4, Victor Charlie.
Stop Kilo 4, Victor Charlie, Golf 6, uniform Tango. You're 5 and 9, hit the
92, Juliet Oscar 54 Kilo Hotel, 5 and 9.
Roger, thanks for the contact, 73.
Delta Kilo 4, Victor Charlie, Papa Charlie, Vallibat. Golf Foxtrot, Kilo November 34. 73, thank you.
Mike?
Papa Charlie, Mdina, Juliet Oscar 20, uniform. Oscar 3 Papa Golf Foxtrot, Kilo November 34.
From Sierra Tango, stop.
Fox Sierra Tango, the Yankee Oscar 3 Papa Golf Foxtrot, Kilo November 34.
Go, Italy Oscar 92, G6 UST. India United 1, Mike. Call for 1, Mike Sierra Yankee. Echo for 3.
Kilo Whiskey, Echo Romeo 1, Kilo Whiskey, satellite.
Delta Fox 8 Whiskey uniform.
Good afternoon. Voilà. All right, boys, girls, settle down so that we can start this event. Voilà. Welcome to everyone for this event. It is truly a great occasion to be here hosting the Amateur Radio League on the International Space Station contact. Eventually, we will be connecting with one of the astronauts at the International Space Station, a first for any Maltese school or entity to be able to do so. This venture would not have been possible without the drive of Brother David Mitzi and the technical ability of the Malta Amateur Radio League, who started this project 3 years ago. Our appreciation goes to them.
During this special event, one of the astronauts on board, Josh Casada, will spend around 10 minutes over a live radio link, answering several questions related to the experience of living in space. Special thanks go to St. Francis School, De La Salle College, and Sacred Heart College, who have accepted to be part of this endeavor. The questions that will be asked to the astronaut Josh Casada have been prepared by students from all the 4 schools, together with the work exhibited in the entrance hall.
Over the past month, these schools have been working hard to integrate the theme of space in their respective school scenario, not only in the extracurricular activities, such as talks and clubs, but also via the curriculum itself. Examples include the theme of space in English literature, whereby students critically exploring the H.G. Wells classic novel, The War of the Worlds, in art through the visual representation of planets, in robotics through coding, and in various other disciplines, proof of which can be seen in the foyer. The theme of space always manages to grab the attention of the young and the old alike, and it is a pleasure today to see such a mixed audience.
To launch now this event, we would like to invite Mr. Manuel Grech on stage to give a more in-depth overview of how the contact will take place. Thank you.
So, distinguished guests, ladies and gentlemen, and boys and girls, I think? No, yeah. Welcome to this unique event. I gather you all know why we're here this afternoon, do you? Going to try to make this as interactive as possible. I'm going to ask you some questions. Do you know why we're gathered here this afternoon? Why? Good. We're going to talk to an astronaut on board the International Space Station. Okay, and you know why it's so unique? You know why it's so unique? What? That's right, very good. Stella Maris College, your school, is the first school in Malta, okay, who was selected to talk to an astronaut on board the space station. So that makes it very unique. That's the good news. This event was supposed to happen last year, actually, in December. But due to we were all set up for this event, and at the last minute, NASA cancelled it because of unavailability of crew. But now they've given us another chance, and here we are. So today we're going to talk to an astronaut on board the space station. Let me talk about this whole event. This is actually a program. It's called the ARIS program, as you can see over there, ARIS. ARISS, that stands for the Amateur Radio on the International Space Station. Okay, this whole thing is a program which NASA and the European Space Agency do together, okay? And this lets students worldwide experience the excitement of talking directly with crew members of the International Space Station, inspiring them to pursue interests in careers in science, technology, engineering, math, and engaging them with radio science technology through amateur radio. I'll be talking about this in just a couple of minutes. So, whose idea was this? So, this is a program, and with this program, we're going to talk to an astronaut on board the space station. So, whose idea was this? Actually, it was the idea of a few radio hobbyists like we are, okay? They had the idea of putting a radio, a piece of equipment, I'll be talking about it in a couple of minutes, on the International Space Station so that astronauts could be able to talk to other radio amateurs on Earth, other radio operators on Earth, or students like yourselves in schools. Okay, so NASA and the European Space Agency accepted this invitation, and here we are. Okay, we're going to talk to the astronaut on board the space station. So who is the European Space Agency? You all know who NASA is, what NASA is. Any idea what NASA is? That's right. Anything which is space related in the United States has to go through the space agency, okay? We have the same thing here in Europe, which is called the European Space Agency, ESA. Anything which is space related, it has to go through this space agency. Actually, Malta is a part member of this European Space Agency as well. So, how are we going to talk directly with an astronaut today on board the space station? Can we call him on his mobile phone? What do you think? No? I've got his phone number here. We can call him. What do you think? Would he be able to call us back? No. And why is that? Why don't? There's no signal. Yeah. Well. You're quite close. The space station is so high above the Earth that your small mobile phone does not have enough power to communicate with it. So we have to do it in another way. And we're going to use a technique which is called amateur radio. This is where amateur radio comes in. So what is this amateur radio? Well, it's a hobby like football, table tennis, biking, fishing, whatever. It's also called ham radio for short, H-A-M, ham radio, okay? Radio amateurs use a piece of equipment like we have here, which is called the transmitter and the receiver. When you combine them in one box, it is called the transceiver, transmitter and the receiver. What does the transmitter do? As its name implies, it can transmit, it can generate a signal, and it can transmit it, okay, through an antenna. We use an antenna as well. So we use this piece of equipment and an antenna. The transmitter generates this signal, and the antenna emits radio waves all out into space. The receiver part receives those radio waves. No, what are radio waves? You have any idea? Anyone has an idea what are radio waves? Yeah. Okay, yes, close enough. That's good. Well, radio waves, no one has ever seen or will ever see a radio wave, actually. But we know they exist, because when we switch on our radio sets in the cars or at home, we can see the DJ talking. We can hear the music there as well. So we know that there is something between the radio station and our radio, so we know that they do exist. Okay? So this transceiver, which is the one we're going to talk to with our astronaut today, okay, can generate a signal and it can receive a signal. So in order to be able to transmit, you cannot just transmit because that's illegal. We need to have a license. Anyone who has this hobby has to get a license to transmit. So what we do, we study a little bit of electronics, we sit for an exam, then we apply with the Malta Communications Authority, and they issue us a license. And they give us a call sign as well. What is called a call sign? Because when we use the radio, we use this call sign. We don't use, well, we use our names, but we use this call sign to communicate. My call sign here, if you can see it, is 9H1GW. It's spelled 9 Hotel 1 Golf Whiskey. Every radio amateur in the world has a unique call sign, okay? Today, we're going to talk to the International Space Station, okay? Your college here has to have its own call sign because we're going to transmit to the space station. In fact, we're going to use this call sign today, 9H1MRL, which is spelled 9 Hotel 1 Mike Romeo Lima. That will be the call sign of the school here. So we will be calling the astronaut using that call sign. The space station has its own call sign today, which is OR4ISS, Oscar Romeo 4 India Sierra Sierra. That will be the call sign of the space station, okay? So that's the call sign the astronaut will be using today. So radio amateurs can communicate using a variety of ways. We can talk like I'm talking to you using speech. We can use Morse code, dadit, maybe you've heard of it. Television pictures. We can also use the moon to reflect radio waves back to Earth. Okay. And these methods enable communications between radio amateurs, okay, across a country, across a continent. Every day we contact, we've got our own equipment at home, we contact other radio amateurs all across the world, in the US, in Australia, in New Zealand, Japan, wherever. And why not? We can use this same technique to contact the astronaut today on board the space station. That's a typical transceiver like we've got here, which we're going to use today. Okay, so this is how we communicate. Over there you can see Mary, who is a radio amateur herself. By the way, this is not only a man's hobby, it's also a woman's hobby. There are many women across the world who are radio amateurs. She is trying to call Joe, the radio amateur, who may be on the other side of the earth, of the world. So she's using her equipment here, her transceiver, and you can see a microphone there as well. Mary is talking into that microphone. Her voice is going through the transmitter part of this her equipment, okay? That transmitter is generating a signal which is going through that blue thing over there, which we call a wire or a cable, out into the antenna which is on Mary's roof. That antenna will emit radio waves all around, okay? On the other side of the world, Joe, which is happening to be listening to Mary, the radio waves from Mary's signal will hit Joe's antenna on his roof. They will go down, the signal will go down this blue line here, which is the cable, our cable, and into the receiver part of Joe's equipment. And he'll be able to listen to what Mary has to tell him. Of course, it works the other way around. Joe can talk to his equipment. His signal will be transmitted by radio waves from his antenna. They will hit Mary's antenna. They go down through her cable into her receiver, and she can listen to what Joe has to tell her. So that is the way we communicate. Joe is talking to Mary, Mary is talking to Joe. That is communication, okay? That is what we're going to do today with the astronaut. So that is a little bit about what this amateur radio is. Let me talk a little bit about the International Space Station. Anyone knows what it is? Oh, again. Go ahead. Exactly. Anything else? Do you know anything else about the space station? Very good. What it is, what it does? Well, actually, it's a station that is going around the Earth. We say it is orbiting around the Earth. Well, anything that goes around something else, we call it is orbiting. The moon is going around the Earth. So the moon is orbiting the Earth. The space station is orbiting, is going around the Earth. It has been inhabited since 2000, so 23 years. It's been there in space for 23 years. It is about 400 kilometers high. And anyone knows what the astronauts do there on this besides eating and sleeping? I mean, do you know? Yeah. Yes, they do, but their main job is to do experiments. That's right, they do experiments, all sorts of experiments. Okay? Pardon? Or okay, all right, okay, good. Well, they're okay. Well, the main job of the astronaut is to do experiments, all kinds of experiments in biology, physics, astronomy, meteorology, all kinds of experiments. That's their job on the space station, okay? So aboard the ISS, the crews are multinational. There were crews from the UK, from the USA, Japan, Russia, and maybe, why not, someday from Malta as well. Maybe one of you will become an astronaut. Why not? I mean, we've got our space agency now, the European Space Agency. Malta forms part of it. The astronauts live there, they eat there, they exercise, they work, they sleep. And obviously, being human beings, they need to go to the bathroom once in a while as well. So they have a toilet up there as well. They can also have break periods where they can relax and enjoy themselves. And this is where we come in, because during their break periods, the astronauts, being radio amateurs themselves, and they have their own call signs, they have a license to transmit, they can talk to other radio amateurs on the Earth or students like you in different schools, okay? Through this program, which is called ARIS. So this is where we come in. That's the look of the ISS from space. Anyone has any idea what these white things are jutting out from? Solar panels, that's right, they're solar panels. You know why they're there? You know why they have those solar panels? Good, to power the space station, because they have no power station up there like we have on Earth, and the only way they can get their electricity is from the sun. Those solar panels, like the solar panels we have on our roofs today, they convert the light rays from the sun, the light energy from the sun, into electrical energy to power the space station. So, some other facts about the ISS. On a clear night, actually you can see it. You can see it with your naked eye because it's so big, it reflects the sunlight. It has been in space for over 20 years. It goes once around the Earth every 1.5 hours. Every 1 hour, 30 minutes, it goes once around the Earth. Okay? Any idea how fast it's going? How fast the space station is going? (3,000 kilometers per hour), a little bit more than that. 55, a little bit less than that actually. It's 25, that's close enough. It's about 27,500 kilometers an hour. That's about 7 kilometers every second. Can you imagine that? It's like going from Valletta to Sliema, which is about 7 kilometers, in 1 second. That's really fast. Can you imagine that? So since it orbits the Earth, it goes once around the Earth every 1.5 hours. In 24 hours, in a whole day, it goes around the Earth 16 times. 16 times every day, okay? Being so fast, the thing is that our contact from the time we establish communication with the space station to the time we lose communication is going to take us only 10 minutes. We have only a 10-minute period to ask the astronaut our 20 questions. Now we may be, if we're lucky enough, we may be able to ask him 20, but so we'll ask him as much as we can, okay? During those 10 minutes, we have to ask him as many questions as we can. It is made up of several modules, which you can see over there. So this is the current crew on board the International Space Station. These are the astronauts that are living on the space station. They have been living there for quite a while now. If we begin from the left-hand side, from this guy, he's from the US, from America, from the United States of America. This guy is from Canada. The third one is from Japan. Actually, he was the astronaut we were supposed to talk to in December. But now, we're going to talk with this guy here, the one in the middle, whose name is Joshua Casada. He's American, he's from the US, and I'll be talking about him in just a minute. This lady here is from the United States, and these last two are from Russia. They are called cosmonauts because they are from Russia. So here he is, boys. He's Joshua, or Josh for short, Casada. He's the astronaut we're going to talk to today, okay? We're going to ask him questions, and he'll be able to answer us back. He's about 49 years old, 50 years old. He's got a boy and a girl, 2 kids just like you. He's graduated in physics, and he was a fighter pilot as well, because he used to work with the Navy. Okay? So life on board the ISS, what do they do there? They're having a meal because they need to eat as well. Okay? When they've got nothing better to do, they just float around. Do you know why they float around? Why they can float around on the space station? Because there's no gravity over there, so they can just float around. They've got a lot of laptops because that's their job there. They're doing experiments all the time, okay? Okay, life can be hectic. They're doing experiments again. Sleeping quarters, well, the astronauts are human beings just like we are, and they need to sleep, okay, as well. So they have sleeping quarters over there. And when nature calls, because again, they are human beings, when nature calls, they have to go to the toilet. That's their toilet over there. A little bit more complicated than what we have at home. Yeah. Shout a little bit, will you? Let's keep the questions for at the end of the presentation, will you? There is no need to go to hospital, actually. When they go down to Earth, there is no need to go to hospital. There can be instances where they can, but it's not normally that they go to hospital. So that's the ISS, the solar panels. It looks majestic, it's nice, it's big. Solar panels gleaming in the sun again. And here we are, here where we come in. Can you see these 2 astronauts? They're talking to someone. They've got a microphone in their hand and they're talking to someone. That's what they're doing. They're talking to other students like you from other schools all over the world. Or they are talking to radio amateurs, to other radio amateurs. They're making a contact with them. Another one with his microphone in hand. And the magic equation. So we said, what is this ham radio, this amateur radio, is this hobby of ours, okay, where we communicate. We've got that piece of equipment, a transceiver. We communicate with other radiometers all over the world. We said what the International Space Station is, this habitable station going around the Earth, the astronauts doing all sorts of experiments there. If we join them together, we got the amateur radio on the International Space Station, which is this program that it will enable us, or is going to enable us today, to talk to this astronaut there, okay? And this is how we're going to do it. Here's what's going to happen. You can see the student here. Well, 20 students of you here have prepared questions to ask to Josh, okay? They'll be lined up here, and they're going to talk through this microphone. So this microphone is like that microphone over there. It's connected to our transceiver, okay? And the student is going to ask the question. His voice will be transmitted by the transmitter part of that equipment there, okay, into this blue thing, which we call the cable, which you can see down here on the ground, these pieces of black and yellow plastic things. The cable is underneath them, sorry, that way. The cable is underneath them, okay? Those things are there so that you don't walk over the cable because you can damage it, okay? The cables go through that window there up into our antenna, which is on the roof. That's our antenna, really. It's up there on the roof, okay? We've got that big antenna over there, up on the roof, okay? Those signals, that signal will be transmitted, okay? Radio waves will go out through that aerial into space. And it will hit the antenna on board the International Space Station, because they've got an antenna over there as well, not as big as ours, but they've got an antenna. It will go through their cable here into the transceiver, into the equipment that the International Space Station will be using, and the astronaut will be able to listen to what we are saying, okay? When the astronaut is going to answer our question, he will talk in his microphone, as we can see over there. The transmitter, his transmitter will emit a signal. It goes through the cable up into the antenna of the space station. Radio waves will be emitted all around. It will hit our antenna on the roof, go down through that cable into our receiver, and we can listen to what he is saying on the public address system we have here. Those are typical actual school contacts. That one was done in the UK some years ago. Another one. And now we have this short video clip, a 3-minute video clip. It shows that there is an astronaut. His name is Tim Peake. He is from the UK. He's been on the ISS a few years ago. And he made this video clip just to show you what actually the astronaut is going to do up there. He has to tune his radio, fiddle with some things. So let's see what Tim has to say.
NA1SS, this is N2SJ, over.
NA2SJ from NA1SS for scheduled contact.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ARIS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics. Now this is the equipment here in the Columbus laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now, because we're travelling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1 Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
So that was Tim Peake with that video clip, and he was showing us how or what he is going to do. Did you see his small transceiver? It was by his side, because everything was floating in there, because there's no gravity in there. Okay, so that's about all I have to say today. A few credits here are in order, and then just a couple of things before I leave. Credits, Malta Amateur Radio League. We would like to thank the Malta Amateur Radio League in Attard, which is actually our radio club in Attard, for lending their call sign, because the call sign we're going to use today, 9H1M MARL, is actually the club's call sign. So we're going to use that. They lended us some equipment there as well. So many thanks to them. They are a Malta team. Okay, I cannot conclude this presentation without introducing my friends here, without whom this event wouldn't have been possible. Okay, here from the left-hand side we can see Andrew. Call sign is 9 Hotel 2 Alpha Victor. Big clap to Andrew. Okay, and Andrew here, Andrew and myself were responsible for installing the antenna on the roof and installing the cables and other things. We have Trevor and Kyle here, Trevor 9H5TS. Okay, Trevor and Kyle are our computer experts. They are responsible for streaming all this event live on YouTube for your parents to see, or anyone else can see us around the world, because this thing is being streamed. This event is being streamed live on YouTube. We've got Dominic here, 9H1M, 9 Hotel 1 Mike. Dominic is our electronics engineer. He was responsible for much of the equipment here, making things work. Okay, he spent a lot of sleepless nights, I can assure you. And he's going to be operating the radio here with which we are going to communicate with the astronaut, with Josh, our astronaut. Okay? And we have another member who unfortunately cannot be here today. His name is Anthony. His call sign is 9H2AS. We can give him a big clap as well. While we read it, we can give another big clap to Brother David there. Yeah, big clap. Brother David, this was actually his whole idea about 2.5 years ago, 3 years ago, and me and Dominic and the others have, well, we'll try to make it possible. Good, great. I was talking about Anthony. Anthony couldn't be here with us. He's a member of the team as well. He's in the UK now. And I'm sure he's following us on YouTube, and we gave him a big cheer as well. So, we like to thank also the Amateur Satellite Corporation of North America, ARIS, this program without which we wouldn't be here today, and the European Space Agency, Gian Pietro, which is our mentor, our Italian mentor. He's a radio amateur himself. He was very instrumental for during our application process, because this whole thing, how much we spent on? About 2 years trying to plan it, and paperwork and everything is quite a complicated stuff. Brother David was with us in the beginning. Stella Maris College, of course. Mr. Manuel Cilia, the head, Mr. Valerian, big clap please. Mr. Stephen Kakia. Brother David. Our sponsors, Tech MT, Gadgets, Malta Digital Innovation Authority. Richard, our photographer here, he spent countless hours with us rehearsing and everything. And Neville over there, he's another. Neville actually is a part of our team as well, and he is today filming part of this event as well. So, 2 things and I'll be off. First of all, what is going to happen? When the International Space Station will be flying close, we will be switching on our receiver, and that will sound something like this. Okay? That is called white noise, that is noise, okay? When the astronaut is trying to call us, because Josh will be trying to call us, okay? We will listen to that sound very carefully, because that noise, the volume of that noise will start going down. And that is the time when we know that we are going to establish communication with Josh, okay? So we have to be super silent, and Trevor here has something to tell you after I finish. Please. Okay? And we need to give Josh a big cheer. Because, just to say, wait. Because he's going to spend 10 minutes of his time answering our questions. This is something that you're going to remember all your life, okay? So when I tell you, when we are about to lose communication with Josh, okay, you have to clap. So let's rehearse it. On the count of 3, I will tell you when to clap, but on the count of 3 now, let's have a big clap and a cheer. 1, 2, 3. Okay? Okay. Very enthusiastic, very good, good. Thanks very much. Okay, so Josh is going to hear you from this microphone. So when I tell you, big cheer to Josh, I will turn the microphone your way and we will do that. Okay, so I leave the microphone to Trev now. He's got something to tell you.
All right, hello, thank you very much for coming. Thank you for supporting this scientific event, Science, Technology, Engineering and Math event, STEM STEM event. We are very excited to produce this kind of event as ARIS Team MT and the Malta Amateur Radio League, together with the support of our sponsors and Stella School. So a bit of logistics, okay? We will call the students to form a line, not now, when we tell you, okay, as you've rehearsed. Be careful on the little step that this stage has, okay? Around 5 minutes before the actual contact, we need absolute silence, okay? Absolute silence. For those of you having mobile phones, we appreciate if you set them to flight mode 5 minutes before, okay? Flight mode, to reduce radio interference, okay? And you can set them to flight mode as soon as you see this flashing light, okay? This flashing light means absolute silence. Absolute silence. Can we test it? Can I hear nothing? Awesome, awesome, well done, okay? And the reason being for the astronaut to hear us perfectly well when we are doing the transmissions. Okay, I'll go back to Manuel. I think we have around 15 minutes now until the actual contact, right? We'll stay inside the hall. You're going to have some music, and we're going to show you a live scene of what the International Space Station is actually seeing this very moment. And we'll leave it on the screen together with the orbital pass that we're expecting to have. Manuel?
Thank you, Trev. Quite informative. So that's our antenna over there. It's on the roof. Okay. So this is what's going to happen. Over here, you can see, this is a live image. Over here, you can see the position of the International Space Station right now. So it's just flying over North America, okay? It has to go up here, maybe you can see this red line, and then it will fly very close to our islands. That's where we will switch on our receiver and try to establish communication with this astronaut. So I think that's about 15 minutes, in 15 minutes. So I think we can give a 5-minute break, have a 5-minute break, don't go anywhere, but we can have a 5-minute break. Okay, you remain seated, please. 5-minute break, and then we will ask these 20 students who are going to ask Josh the questions to come up here, like we rehearsed it yesterday or the day before yesterday. We're going to use this microphone to speak in, okay? And we'll see how it goes. Just one thing. Okay, here actually, this is the space station live. There is a camera, there are cameras there on board the space station, and you can see it. All right. Live. You can see the speed here. The speed of the space station, 27,611 kilometers an hour. It's going right now. That's quite fast. And it's the altitude, the height above the Earth is 412 kilometers. Okay, so, okay, let's have a 5-minute break. Please remain seated, and then we'll try. One last thing I would like to tell you is that this is an experiment. Okay, this is the first time we're doing it here in a school in Malta. It's an experiment, so anything can go wrong. Hopefully everything will go right, but anything can go wrong, and we may not establish communication with Josh. Maybe he will have problems with his equipment or something, but we'll do our best. Okay, you've been a nice audience so far. Thank you very much. Thanks. Another cheer for our team here in order.
Tini, okay. Okay, please settle down, be seated. We are less than 10 minutes away from contact. Students are forming the line. And pretty soon you're going to see the beacon, okay? Pretty soon you're going to see the beacon, which signifies that your mobile be put on flight mode and absolute silence, okay? As soon as you see the flashing light, mobile phones on flight mode and absolute silence. Students, please prepare yourselves in line. Well done, very proactive. Proceed. And Emmanuel is going to come here. Manuel. So, up. Okay, logistics in your end. I'll give you the timer of the actual event.
Okay, thanks. Mela. Mela, please, silence. Like Trevor told you, we need absolute silence. Well, this space station, you can see it, it's over Canada right now. That is live. Okay, it's over Canada. Now what's going to happen, so Canada's over here, the station is over here. Here we are. Okay, so it has to travel all the way to Malta. In about 8 minutes time, we can see the speed at which it is traveling, 27,600 kilometers an hour, 422 kilometers high. Okay, so when it's closer, we will switch on our radio and we will hear that noise. The students here are going to ask the questions one at a time. You'll be speaking in this microphone, okay, like we did yesterday, and hopefully Josh will be able to hear us and we'll make contact with him and he'll answer our questions. So that's in about 7 minutes? 7 minutes. So try to be quiet, but when we tell you, you have to be very, very quiet. Okay? So we'll have an idea where the space station is at the moment. It's over the North Atlantic. It's over the North Atlantic Ocean, okay, and it's approaching. There we are. Malta is somewhere over there. I'm still steady, or no problem. Still steady. Malta is over there, and the space station is somewhere over here. 6 minutes. So we're going to talk to this astronaut today, and as we've told you, say your questions as clear as possible, so that Josh will be able to listen to us and he will answer our questions. So probably right now Josh is relaxing because it's his, just reminder, just your name, the age, okay, and don't forget to say over. When you finish the question, you say over. That will signal Josh to start answering the question, okay? So he's probably in his break period right now, relaxing and fiddling with his radio, trying to set up his radio so that we will communicate with him. 6 minutes. So over the North Atlantic right now. You can see the altitude, which is a little bit different from what it was a few hours ago. Actually, the space station, they have to do some maneuvers in orbit because of the debris, because in space there is a lot of flying objects, things, satellites, dead satellites, parts of rockets. They're orbiting the Earth, and they can cause a safety. They can be unsafe for the space station because they can collide with the space station, and obviously disaster. So sometimes when they know that there is a piece of a satellite or something in the orbit, in the same orbit, they will have to do maneuvers. Either they make the space station go up a little bit high or lower in its altitude above the Earth so that it will not collide with these objects. So 3 minutes. So that's the space station over here. Okay, it's still over the North Atlantic. You can see it over here. Malta is over here. This is our school here in green. Traveling very fast, so in a few minutes we'll be able to hear. I'm going. You can see our antenna all set up. It will start moving slowly by itself. You can see it turning by itself. It's pointing automatically to the direction where the space shuttle is coming from, from the space station is coming from. This thing here, that white circle here, is called the footprint. That is the range of the communications range of the International Space Station. So anyone within that circle there will be able to communicate with it. So when that white circle touches the green, that is where we are, we can start trying to establish communication. To hear the noise going down, so quiet. Oscar Romeo 4, India Sierra Sierra from 9 Hotel 1 Mike Romeo Lima. Do you read, Josh? Oscar Romeo 4, India Sierra Sierra from 9 Hotel 1 Mike Romeo Lima. Do you read, Josh? Oscar Romeo 4, India Sierra Sierra 9 Hotel 1 Mike Romeo Lima. Do you read, Josh? Oscar Romeo 4, India Sierra Sierra 9 Hotel 1 Mike Romeo Lima. Do you read, Josh? Oscar Romeo 4, India Sierra Sierra 9 Hotel 1 Mike Romeo Lima. Do you read, Josh? Oscar Romeo 4, India Sierra Sierra 9 Hotel 1 Mike Romeo Lima. Do you read, Josh? Oscar Romeo 4, India Sierra Sierra, Mike 9 Hotel 1, Mike Romeo Lima. Oscar Romeo 4, India Sierra Sierra, 9 Hotel 1, Mike Romeo Lima. Do you read, Josh?
Niner Hotel 1, Mike Romeo Lima. This is Oscar Romeo 4, ISS. I have you broken but readable.
Okay, Oscar Romeo 4, India Sierra Sierra 9 Hotel 1, Mike Romeo Lima. We read you, Josh, now. Good afternoon to you and welcome to Stella Maris College on the island of Malta. How do you read us now? Over.
Welcome aboard the International Space Station, Malta. I read you better and better as we get closer and closer. I'm excited to answer some questions today. Over.
Thank you very much, Josh. It's so nice to hear your voice this afternoon. Are you ready for your first question?
Absolutely ready. Over.
Okay, it's that. Okay, go ahead.
Daniel Grech, 12 years old. What do astronauts normally eat or drink on the space station? Over.
Hello, Daniel. Well, we have a variety of foods that are in bags, and we can warm those bags up. But we have everything from pasta. I'm about to have some pasta, which is probably familiar to you. That's going to be my lunch today after it is warmed up. But we get all kinds of meats and vegetables, but they're all in these bags, so they're not fresh. Every so often we can get some fresh food that comes up on a cargo vehicle, but it's only good for a couple days. And sometimes your family can send you snacks. So I've got some licorice that I love, and I love to eat some chocolate before I go to bed. Over.
Giuliano, 9 years old. How do you sleep in space, and is it comfortable? Over.
Hi, Giuliano. We sleep by putting a sleeping bag and tying it to the wall. And then you just get into the sleeping bag and you zip it up. And it is incredibly comfortable because you're not even laying on your back. There's no pressure on your body. And you just hang out there and your arms float and your head floats right where it wants to be. So it's really relaxing. The only problem is when you're working throughout the day, your body's in the exact same position. So you have to remember, this is not the time to be sleeping. This is the time to be working. Over.
Matteo, 11 years old. What do you do in your free time? Over.
Hello, Matteo. Well, we don't get a ton of free time. We start our work days at 7:30 in the morning, and we go until 7:30 at night. And so by the time we have dinner and get all cleaned up, it's almost time for bed. But sometimes when we get a break, either during the day or on the weekend, we like to take advantage of looking out these incredible windows and seeing the beautiful planet below. This planet is so gorgeous, and it's just an amazing perspective from up here. When we're not doing that, we can watch movies sometimes. We do that as a crew, and we have an ability to call our family when we need to. Over.
Mikhail, 11 years old. How long is the training to actually go in space? Over.
Mikhail, it usually takes at least 4 or 5 years of training at NASA before you're on a rocket headed to the space station or to a different mission. For me, I was actually training for 9 years, and it's not just because I'm slow. I was assigned to a different spacecraft that ended up not being able to launch on time, so I got moved over to a different spacecraft. But the training is pretty fun, but not quite as fun as being in space. Over.
Benjamin, 11 years old. Why do astronauts wear spacesuits? Over.
Hey, Benjamin. Well, we wear them for different reasons when we're doing different things. So, for example, a couple months ago when we went outside and did a spacewalk, we installed new solar arrays on the space station. And so we're wearing a spacesuit there because if we don't have one, we don't have any oxygen, and we are not maintaining pressure, and so the human body can't survive. So in that case, the spacesuit is really like a little spacecraft. And it's your space vehicle for getting around, and it's pretty amazing. But we also wear them in our spacecraft when we go up and down from the space station, and those we wear just in case something bad happens. And that spacesuit will keep us safe even if the space vehicle itself is not safe. But right now, I'm not wearing one. Over.
Nicholas, 13 years old. Is there a maximum time limit for staying in space? Over.
Boy, I sure hope so, Nicholas, because I've been up here for 5 months, and I love it up here, but I also am anxious to get home. But the time limit tends to be based right now on how long our spacecraft is healthy. And we know that it's going to be healthy for a very, very long time, but we end up being very conservative and making a limit and saying, hey, let's come home way before we are at all wondering if the spacecraft is safe. So right now, we tend to keep a spacecraft up here for maybe no more than 7 or 8 months, but a person can stay up longer. Maybe they can come home on a different vehicle. Over.
Alessandro, 12 years old. How do you stay healthy physically and mentally in space? Over.
Hi, Alessandro. Well, I'll tell you what, we work out 2.5 hours a day. We do biking, but it's not a real bike. It's a stationary bike that doesn't even have a seat or handlebars. We do this equivalent of lifting weights. So we work out our bodies very, very hard physically. But for mental stuff, I like to read electronic books. I like to talk to my family and friends on the phone when I can. And, you know, again, watching movies is always super fun when you get to hang out with your crew. Over.
Zach, 9 years old. When you're going up in space, crossing the ozone layer, does it hurt? Over.
Hey, Zach, I wouldn't say that it hurts. So when we accelerate off of the planet, we essentially go straight up and we work hard to get through the atmosphere, and then we tip over and start going fast so that we can go around at the planet and then get into orbit. And so every time we accelerate like that, there's pressure on our chest. And it kind of feels like, you know, if you have a big brother or a big sister, it feels like they're sitting on your chest. But it doesn't really hurt, and then as soon as you're into orbit, you're free-floating, and it's incredible. Over.
Max, 12 years old. What side effects do you get when attending from space? Over.
Hi, Max. Well, when we come back, even though our muscles are strong and our bones are strong, we haven't felt gravity for a while. And so our inner ear, you kind of have a little bit of problem kind of maintaining the ability to stand up. So I'll be getting some help for sure when I get back, but it takes a little while to kind of get reacclimated to life on Earth. But that's probably the biggest thing. And then, you know, I haven't seen the sun in a while, so I have to be careful there too. Over.
Liam, 11 years old. Can kids go to space? Over.
Hey, Liam, that is an incredible idea. Kids could go to space. We haven't had kids in space yet, and I'll tell you what, I would love it. I love hanging out with kids. Kids have such a great perspective on life, and they're fun, and they're funny. I would love to have a kid up here or two during my mission, but unfortunately we don't have any up here today, but I'm going to get home soon and see my wife and kids, and that's very exciting. Over.
Jack, 9 years old. Did you discover something from another galaxy or planet? Over.
Hi, Jack. Well, I can't take credit for it, but we certainly are. We've got experiments here on the space station that are looking way out into the universe to collect data. We're solving problems and issues within the universe, and we're learning so much. In fact, we have an experiment that's on top of the space station that's collecting all these cosmic rays. And we've discovered that there's some really neat physics out there. And we've got another one that's looking at neutron stars way, way far away and discovering really interesting properties of neutron stars. So I can't take credit for it, but we are seeing a lot from outside our solar system for sure. Oh.
Samuel, 11 years old. What does space food taste like? Over.
Hello, Samuel. Well, I'll tell you what, after about 5 months, it's all starting to taste the same to me. But we have a variety of bags of food that we can heat up. Some of the food that we have is dehydrated, so we have to inject warm or cold water into them. My favorite thing to eat up here had been pasta, but I think recently I've switched over to my breakfast cereal. I miss cereal with milk, and I get that up here, and that tastes pretty much like it does on Earth. Over.
Antonio, 12 years old. How does it feel like living in low gravity? Over.
If you've ever been in a big body of water, maybe that beautiful Mediterranean,
Oscar Romeo 4 India Sierra Sierra 9 Hotel 1 Mike Romeo Lima. Do you read, Josh? Okay, it seems that we're going to lose communication, Josh. Oscar Romeo 4 India Sierra Sierra from 9 Hotel 1 Mike Romeo Lima. This was fantastic, and the students want to say a big thank you. Oscar Romeo 4 India Sierra Sierra 9 Hotel 1 Mike Romeo Lima. Thanks very much, Josh. Thanks for all your help. Stay safe. God bless. Thank you very much. Mala, that was, just a second, wait a minute. That was it. How exciting was that? Huh? It was exciting. It was exciting. You were really good. You were all clear in your words. That was an astronaut talking to you from the International Space Station. That's fantastic. How many questions did we manage to, Tom, how many questions did we manage to ask? 13 out of 20. No, that's good. Okay. I leave it to Mr. Valerian or Mr. Cilia.
Grazzi li oġobkom tinaqdu magħna biex nkunu nistgħu nagħmlu dan il-kollegament. Grazzi kbira mill-qalb tmur lil Brother David illi kien il-moħħ illi bena illi beda dan il-proġett. Grazzi kbira wkoll tmur lit-tim ta' Manuel, Dominic u sħabhom tal-Malta Amateur Radio li kieku mhux bis-saħħa tagħhom ma stajniex nikkomunikaw. Ħaqhom ċabċipa. Grazzi lil Mr. Kakija tas-support illi dejjem tagħna, grazzi wkoll lilkom illi oġobkom illi tieħdu sem b'mod attiv f'dan il-proġett, kif ukoll grazzi lil Mr. Valerian illi ħaħsib jikkoordina dan il-proġett. Mela, biex nagħlqu din l-attività ser nippreżentaw ċertifikat ta' tifkira lill-istudenti illi matul dan is-sajf kienu qegħdin involuti fil-Space Club kif ukoll illum saqsew il-mistoqsijiet lill-astronawta.
Mela, we've got a small certificate of participation to the 20 students that prepared the questions for Josh, and if you would please come over on the catwalk. Mela, number 1, Daniel. Okay, they're one after the other. Matteo Rapa. Mikil Shwireb. Benjamin Aquilina. Nicholas Azzopardi. Alessandro Borg. Jack Cassar Conti. Max Paul Vella. Well done. Liam Brinkat. Jack Pirotta. Samuel Vella. Antonio Esposito, Jan Straud, Ethan Bonanno, Luca Borge, Thomas Falson Sherry, Etienne Chiberras, Alexander Briffa Desjardins, Zachary Lee Grech. So that was it for today. I hope you all enjoyed it. Thank you very much for your participation. Thanks.